Good afternoon, ladies and gentlemen. I'm Qing, a technical support engineer of Asia and Oceania Center. Today, I'm so happy here to have a presentation about SuperMap iDesktop operation on 3D and AI. Our presentation has three parts. First is SuperMap iDesktop introduction, and the second one is 3D operation using iDesktop, and the last one we're going to talk about the AI GIS workflow based on geospatial deep learning. The first, we just briefly introduce SuperMap iDesktop. As we already know, SuperMap products are built based on this 5 key technology or BITCC. There are all the products of SuperMap, and the products we are going to use SuperMap iDesktop. .NET and iDesktop X, which belong to the terminal GIS for PC. Then let's take a look at what iDesktop.NET and iDesktop X. SuperMap iDesktop.NET is an enterprise desktop GIS application and development platform. It is a plugin GIS application built by SuperMap iObjects C# and the desktop core library. SuperMap iDesktop X is a cross-platform and the plugin GIS application and the development platform built by iObjects Java, Python, and iObjects for Spark. The both desktop have the capabilities to achieve data processing, analysis, 2D and 3D mapping and publishing, and so on. They also support multiple spatial databases and enterprises databases. There are more than 200 analysis operations in SuperMap iDesktop. Besides the basic analysis, just like the vector data analysis, network data analysis, SuperMap iDesktop also supports spatial big data and distributed spatial reconstruction and streaming computing. Besides SuperMap iDesktop X also supports the machine learning and deep learning. Here we can see this example about a 3D scene which show it is displaying the huge 3D scene using SuperMap iDesktop. And the next example is to operate the 3D scene using gesture, which is based on SuperMap AIGS technology. The next, we are going to demonstrate how 3D and AI work in the iDesktop. Let's first take a look at this 3D operation using iDesktop. Firstly, let's see what kinds of 3D data can be supported in SuperMap iDesktop. There are terrain data, oblique photogrammetry, beam, points, cloud, and manual models, and so on. All these models can also be integrated in the SuperMap iDesktop. For example, the road, terrain, and beam can be integrated with oblique photography, and we can also integrate beam with terrain data. The 3D scene can not only displayed in iDesktop, but also can be supported to display and apply in the browser and the mobile. Besides, VR and AR applications can be achieved with this 3D data. Then the next, we are going to demonstrate how 3D applied in the iDesktop. There are two types of scenes in iDesktop: plane scene and the spherical scene. The plane scene is that the surface of the Earth is spread out into a plane, and it can only support planar and projected coordinate system. And this spherical scene simulates the surface of the Earth with a sphere, supports data of geographical and projected coordinate system. 3D layers are organized in the iDesktop by a screen layer, general layer, and terrain layer. The screen layer can only manage the static graphics, such as the logo descriptions, without any geographic information. And all the 2D data, 3D data, cached data are organized in the, by the general layer, and the terrain layer only organize the DM, grid, and the terrain cache. The next we are going to do a demonstration to show how to quickly model by 2D vector data. Here we are going to stretch the 2D buildings to 3D model and textures to these 3D buildings. Then let's go open the iDesktop. This is the homepage of the iDesktop, and here we open the data. All the in the SuperMap, all the data are managed by the data source, and all the data source scenes maps are all managed by the workspace manager. And the top of the menu, these are all the main functions of the SuperMap iDesktop. Just that you can find the data processing and the 3D data and all analysis of the menus. And here the center of the desktop is the window to show the maps or the things. Just like if we end here, we find the data. All the data are managed in the data source. Here the 0.9 polygon, and here then like we add the buildings, the two buildings data sets to the to a new map, and the data will be displayed like this. It will be displayed in the map like this. And if we open it to a new spherical scene, the spherical thing it simulates our Earth, and we can zoom to a location to the locate to the buildings. Here we can see this is a 3D scene, and the data is 2D data. The next we are going to do is to stretch these 2D buildings to 3D models. So then first, select the building one. Here we are going to find these things menu here at the top of the interface, and then here contains all the basic operations of these things. And if we want to stretch these 2D buildings, we'll go to the styles and then find the extension ribbon. And here we set the altitude mode as relative to ground, and then here we can set the altitude of the buildings, and we can set the extend altitude of the buildings. Here, just like we set it as 100 meters. And then the buildings now it's displayed as 3D models. And the next, we can add texture to the buildings. Here we can set the side texture. We can, if there are texture in the attribute in the attribute table, you can select the side texture and top texture. Also, you can select the texture from file. Here we just select this one, and then we change the repeat type. We set the U select 10 and the V set 5. And here we can see the texture is added to the buildings. And then we add the top texture. Okay, we also select file. Here we select to the buildings. And then here we finish the building rapidly modeling, and then we can see this the building 2. Here we can open the building 2's attribute table. Here we can find that there are fields or properties, the roof and bridge, and here also the side texture, top texture are defined in the attribute table. So here we are going to set the buildings, the styles. And the first, we also select relative to ground, and the extend altitude, we select the stretch height. Here we can stretch height attributes have the different heights in the, and then we also add textures. Here we select, here we can select side texture, and top texture, we select top texture. Here we set the U size, and the U size we set 1. Then the roof should be like this. And then we can change the foreground color of the buildings. We change it to white, and also the building 1, we also change the foreground color at white. So here we finish the buildings stretching from 2D vector data to 3D models. And then let's go back to our PowerPoint. Besides, SuperMap also supports to symbolize the 2D point, line, and polygons with 3D symbolization. Here we are going to add trees, roads, and the water to this scene. Here we find the tree, road, and water. We add to the current scene. You can see they are all 2D vector data. The first, we are going to set the tree. Here, let's see the attributes of the tree. There are 3 types of the tree: tropical tree, and willow, and coniferous tree. And here, we are going to use the semantic mapping to set the different 3D samples onto the trees. Here we create semantic map. And the expression we set as tree type. And then we set the style for each tree. The first tree is coniferous tree. Here we find the symbol, the tree. We use this one, and we set the scale of the tree. 6. And then let's set all the trees. Tropical tree, we also find we select the coconut tree and set the size here. And then next, the willows we set and this one. And we also set the scales of the tree. Here we can see all the trees are symbolized with 3D symbol. And then the next, we're going to set the road. The road is a 2D line, and here we are going to set the symbol to the road. We find the layer style setting and a 3D line symbol. Here we use the road and set the Y's. Okay. Here we can see the line are symbolized with 3D road symbol. Then the next, we are going to set the water effect. We find the water layer and layer style settings. We can find field library. We use the num-com-lake, and here we first need to also set the altitude mode to the water layer. And then here we can see the water effect added to the water layer. So here is about the 3D symbolization. And then the next, SuperMap also supports the animation model. Here we are going to add a dynamic logo on this building. Here we find the edit board. This layer we add to the current scene, and then here we also save the style, the ultimate, and the bottom altitude. Let's see, 50, and the extent. And the extent altitude we set 30 meters. And then we add texture to the and vertex board. Here we select a GIF. Then the layers are displayed with the dynamic logo. Besides, we can add all these data to the scene and process them with the same methods. Then you can get a final 3D scene like this. Here is the final result of the 3D scene making from 2D vector data to 3D models. Now let's continue our presentation. Besides modeling in SuperMap at desktop, the most important application of 3D is 3D spatial analysis, such as the visibility analysis, channel analysis, scanner analysis, and flood analysis are all supported in SuperMap at desktop. Now let's go back to our iDesktop to show a few examples of this. We first close all this workspace, and then we open a 3D scene of Beijing Center. Here we find this 3D analysis menu, and here we can see the analysis of slope and aspect, iso9, flooding, and visibility, viewshed. Here we can just now viewshed. We can add a point at the building, and then draw an area. The red area is invisible and the green area is visible at this location. So we can also add the visibility analysis. The green line means you can see from this point to here, but the red line cannot be visible. So if you stand here and here, these 2 points are invisible. And also there are another analysis for the timings. I just to show two of this. You can have a try after our webinar. And then Um, let's continue our presentation. The last part, we will introduce the SuperMap AIG's workflow based on Geospatial deep learning. The SuperMap AIGIS technology consists of three parts: the GeoAI, AI for GIS, and GIS for AI. AI for GIS uses AI to enhance the functions and the user experience of GIS software, such that the AI interaction is based on the AI for GIS technology. And GIS for AI uses visualization and analysis technology of GIS to perform spatial visualization and further spatial analysis of AI output results. And the GeoAI is a spatial data processing and analysis algorithm that integrates AI, includes two parts: geospatial machine learning and geospatial deep learning. Machine learning is the core of the AI. Taking SuperMap as an example, users can solve a variety of GIS application problems such as spatial clustering, spatial classification, and spatial regression based on geospatial machine learning. And geospatial deep learning can directly identify time and space features from geospatial data. With geospatial deep learning algorithms, it can realize 3D data analysis and image analysis in SuperMap. Then let's talk about the core of the AI geospatial deep learning. The algorithm of geospatial deep learning, just like semantic segmentation, instance segmentation, object detection, with these algorithms, GIS functions such as binary classification, land use and cover classification, object extraction, realized. Then let's have a look at the workflow of GeoAI. The first step is data acquisition and preparation, and then the next step is to build models, then use the trained model to realize model learning and prediction. Firstly, we should know what we are going to do. It determines what kind of function we are going to use. Just like if we want to detect airplanes on trees, we need to use object detection. Also, we can use binary classification if we want to extract buildings or roads. Here is an example of palm tree detection. The palm trees can be detected in the remote scenes images, and we can get the statistic of them quickly. This is building extraction using binary classification. The result is a two-value grid, 1 and 0, where 1 represents buildings and 0 represents other objects. This is land use and cover classification using multiple classification, which the rivers, buildings, farmland, and forests are classified. Let's have a look at the detailed contents of every step after we decide what to do. In the data preparation step, we need to connect the data. And the most important step is data processing. We need to check the data's quality and convert the data to the, we need to convert the immediate data to TIFF format, and we should make labels in the first step. And then in the model building stage, we need to select the algorithms and see the learning rate and verify the accuracy of trained model. Model training and model evaluation and model updating are a loop procession. The last step is to use the trained model to generalize model learning and prediction. Such as we are going to detect palm trees, we need to make labels. Firstly, we can take parts of image data to draw the palm tree contour, and the labels is a vector data stored in the data source with UDB or UDBX. Then the image data and the label data are used to produce the training data using the training data creation tool. The tool we can find in the SuperMap iDesktop X. Then in the model building step, intersection over union parameter is used to evaluate the accuracy of trained model. Then we will get a trained model with SDM format after a long-term training. With the unified deep learning model, we can realize model application using iDesktop or iServer. iDesktop X machine learning is a tool with zero code. There are also two services can be published in iServer to realize the model prediction, data science service and machine learning service. The function corresponding to each step in the iDesktop X can be found in the machine learning toolbox. Firstly, to create training data and then build the model. Finally, use the trained model to detect or classify objects. Then let's demonstrate how to detect airplanes in the remote sense image. Here we prepared a high resolution image. We used one part of the image to draw airplane labels. Within image and labels, we are going to create training data. Let's go to iDesktop X to demonstrate it. Here, I already open label data and the image data. The image data is the TIFF data. Here we can add the plane to the map. And we also add the labels to the map. Here we make labels of this part, and then we train. We are going to train model with this sample data and the image, then to detect all the planes in this image. Here, the first we should start the Python environment. The SuperMap GeoAI in the iDesktop X based on the SuperMap objects for Python. Here it is started now. And then we find the toolbox machine learning imagery analysis. Here we can see the tools create training data, model training, and object detection, binary classification, multi-classification, all this. The first, we should create training data with this labels and the image. The image data set with the plane and the label data set with label. Here we see the picture size much smaller. Here is based on your computer's GPU, and then the training data usage, we use object detection. So here the class field, we select nothing, and then we output the results. We find a new folder to store the result. And then here we run it. The training is a learning progress, so it may need sometimes to train the data. Here we can see the we can go to find the train result, the data training results. Here we will get the we will get the training data results, and then we are going to use this training data to training the model. Here with the first we should select the training data path. We just select this training data. Select the whole folder, and then we are going to set the algorithm of the deep learning. Here we use object detection, and the algorithm file is the training config file. We select the object detection, and the epoch is the number of traversing all samples in the training. It is the training times. The default one is 10, and actually, if you want to get FAM model, it needs more than maybe more than 20, 60, or 40 times. It all based on the accuracy of the results. And here with the batch size, we set it at default. The learning rate is the step size of updating model weights in the training. Here we can keep it at default, and the training log file we output the files. And here we also set the output path of the model and run it. Because this the training is a time exhausting step. Here I just show this how to set the parameters, and here I already trained a model before our webinar, and when finished the training, we will get SDM model here, like this. And here we just use this model to predict the the result. And here we use the object detection, and here we see the model file displaying, and here we say all this at default, we just run it, and it also takes a few times to finish it. We can leave the progress running, and here we can go back to our PowerPoint, and let's make a summary of this presentation. First, we briefly introduced SuperMap iDesktop.net and iDesktop X. Then we demonstrated rapid learning modeling and 3D analysis using iDesktop.net. And next, we learned about SuperMap AIGs and how to realize object detection and classification using iDesktop X. You can go to our official website to download the desktop products and sample data to have a try after our webinar. We also welcome you to connect to us to learn more about our products. Thank you for your listening. See you, and then let's go back to our iDesktop. Here we can see it already finished. Then we add the result to the map. Here we change the style of the result. So here we can see all the planes are detected in the map. So I think this is all for my presentation. Thank you.